Hi, and welcome to Failurology, a podcast about engineering failures. I'm your host, Nicole.
And I'm Brian, and we're both from Calgary, Alberta, Canada.
Our podcast journey has definitely been a wild ride, and we are immensely thankful for all of your support throughout the course of our show, especially to our Patreon subscribers who listen to our extra bonus episodes and provide a little extra support to our show to help us upgrade our things and make this show better.
We're still making less than minimum wage per hour of time that we put into this show, though.
Brian, don't tell people that. Don't go into podcasting for the money. I can assure you that. We do this because we like it, and it's our hobby.
And I have a face for radio, so this works out very well for me.
So all that said, we do need a little bit of a break this summer, and we didn't want to stop giving you those engineering failures that we know you love.
So today's episode is one of the mini failures we featured on a Patreon page in the fall, the Gimli Glider, an Air Canada 767 that ran out of fuel while it was in the air.
So as it happens, we recorded the intro to this episode, and our intention was to attach the mini failure that we had recorded last fall and put on our Patreon page. It was mini failure number 7. But after doing that and listening to the audio for the mini failure, we didn't love it. And so we're re-recording that mini failure today and bringing you kind of a new episode. So if you aren't on our Patreon, you wouldn't have heard this. But if you are, our notes are still the same or similar, but the tangents probably will be different because we did record it so long ago. But we just weren't happy with the product that we would have been putting out if we just attached that original episode. And so we thought that we would re-record it. So this is our 2022 take on the Gimli Glider. Brian, as you know, is definitely the plane expert on our show. I remember back to the first plane failure that I covered before Brian joined us, and that was Air France Flight 447 that I covered on episode 9. And it was like learning an entirely new language and very, very challenging for me to wrap my head around what was happening. And I say this as a mechanical engineer. So the concepts are not new to me, but all of the things that go into airplane design, things that I definitely don't cover in my day-to-day engineering job. I mean, I do HVAC and plumbing, completely different, completely being the relative term. It took me a while to figure out what was happening. It was really, really hard. So I'm glad that Brian has joined us. He provides a lot of insight, important insight into these plane failures, and definitely helped me appreciate these types of failures that much more. And honestly, now these episodes are some of my favorite. And I think it's because, Brian gets so excited about the failure and he knows so much information. We have notes that we share, and I read, we read along through the notes and make sure that we cover all the points that we want to cover and all the facts are there. There's so much intricate detail that goes into a lot of these failures. And Brian will just go completely off script, I guess you could say, with these facts that I just don't know how he knows all of this information. I am in awe. It's fascinating to watch.
I don't know, I've always liked planes. Planes have been a large part of my life for basically my entire life, so it's just one of those things that you read something about it and it just sticks in the back of your mind, and then I'll remember it when we're recording an episode about planes, or I just read it and I just didn't put it in the script that we follow. So one or two of those possibilities.
So we do still want to give you the full mini failure experience. So we are going to treat this as if it's a mini failure and re-record that style in its entirety. So without further ado, here's our new take on the Gimli Glider. Hi, and welcome to Failurology, a podcast about engineering failures. I'm your host, Nicole.
And I'm Brian, and we're both from Calgary, Alberta, Canada.
Welcome to what was our 7th mini failure episode. We're bringing you engineering failures in bite-sized pieces.
Make no mistake, these are still significant failures, but they either have pretty straightforward causes or not enough information available for a full episode of Failurology.
We have a list of failures, an ongoing list of failures that we continually add to. Some of these we just haven't been able to dig up enough information for a full episode, but we still think they're really cool and we want to tell you about them. So that's kind of where this show is coming from.
These episodes are also just the failure, There's no news segment, and there's no ads, for now at least.
It's like Failurology Light.
This week's mini failure is about the Gimli Glider, an Air Canada 767 aircraft that was going from Montreal to Edmonton that didn't make it all the way to Edmonton. On July 23rd, 1983, shortly after 8 p.m. Central Time, the fuel pressure alarm sounded in the cockpit for the left side engine. The pilots assumed the fuel pump failed and turned off the alarm since the engines were gravity fed in level flight. Then, the fuel pressure alarm sounded for the right-hand engine and they diverted course for Winnipeg. Almost right away, the left engine failed and the pilots planned for a single engine landing while simultaneously communicating with Winnipeg and trying to restart the left engine. Then, the right engine also failed. Since a scenario with no engines was really ever expected to occur, this had not really been covered in training. Seems like an oversight. It's not like you can pull over to the side of the road like you can in a car. Having gone through a bunch of this training, a double engine failure is not really something that ever comes up, or a 3 or 4 engine failure. We do a ton of training with single engine failures and operating in single engine configurations, but to have both engines go out in a modern jet aircraft is very, very unlikely.
Brian, what was the failure that we covered where the rear engine exploded and cut the controls for the other two engines? Was that
Yeah, so that was United Flight 232, and that happened in the late 80s as well.
because that flight had a similar scenario where they essentially thought that what happened would never have happened and therefore they had no plan for it, which I still think is a little silly. I get that the likelihood of both engines failing is very slim, the risk is low, and that having two engines offers you some redundancy, a third even more redundancy. But I do still think it's a little bit silly to not at least have some type of plan. Maybe this isn't a scenario you run every day, but maybe this is one you at least cover. It's somewhere in the textbook that you cover and you read over it once. And so that if you're ever in this situation, you can think back to that time. But do they really not cover this in flight training still to this day?
Yes, so it is possible to simulate a double engine or a triple or quadruple engine failure in the simulator, and it is touched on fairly briefly as part of the simulator experience for in-person flight training. Obviously that's not a component where you're going to fail both the engines. For initial multi-engine training, part of that training does consist of usually shutting down an engine, or certainly operating with only one engine out of the two operating, and single engine operations of aircraft in a simulator. That is definitely part of the training program. If you lose an engine on takeoff or if you lose an engine in flight, so the pilots are trained on how that aircraft operates in a single engine configuration with reduced operating speeds due to losing an engine.
Interesting. I guess you can create, I've seen in movies where a flight will happen that's catastrophic and someone will go back into the simulator and try to recreate those conditions. And we've talked about it on other failures that we've looked at. They're all kind of blending together, but I know there's one we've covered where they've never been able to successfully recreate a successful landing of that failure. And maybe, I don't remember which one it is.
Yeah, I believe it was United 232 where that happened. That they did rerun a bunch of those profiles in a simulator with losing all the hydraulic power, from that engine that was in the tail when the fan blade separated, and it was largely not possible for people, given the same conditions that they were working with in flight, to basically salvage that airplane and bring it back into back to the ground in the same or better condition than the flight crew was able to bring United 232 back to. That's one of the really neat things, I think, and one of the really good things about simulators is you can simulate so many different parameters, from weather, the weight of the aircraft, various failures. Whenever you go to sim, you usually wind up with some fairly ridiculous scenarios that basically unlikely to ever occur in flight. But that's also part of the simulator training, is that you almost overload yourself with so many different scenarios that you need to respond to. So that way, if something ever does come up in an actual real life emergency in flight, you've trained yourself to a much higher level and degree and standard than what you would need to deal with something that happens in flight.
That makes sense. Seems like a good process to over prepare. I like to be over prepared. Is that maybe that's the engineer in me or my slightly type A personality? I definitely like to be prepared. Anyways, back to Gimli.
In preparation to land in Winnipeg, the aircraft was at 10,700 meters or flight level 350 at this point. So 35,000 feet above sea level is the altitude that they're flying at when they experience this engine failure. And they're partway between Montreal and Edmonton at this point, and we'll explain why they run out of fuel in a little bit here. But they are not very close to their destination. Like they've run out of fuel considerably back from their destination. So for people that aren't from Canada or don't have knowledge of where these two cities are in Canada, Edmonton, where they were going, is in the province of Alberta, and that's on the western side of the country, and Montreal is on the east side of the country. So there's quite a distance between the two cities, and they run out of fuel essentially halfway between the two cities.
I mean, I've never flown from Montreal to Edmonton, but I've done Montreal to Calgary, and Calgary's pretty much straight south of Edmonton by about 300 kilometers. And I believe that flight is 4.5 to 5 hours. So they had about 2 hours, I would say, left in their flight when they lost both engines. Speaking of which, when they lost both engines, unfortunately, they also lost almost all of their instruments, except for a few of the basic ones that were powered by battery. The 767 was one of the first jets with an electronic flight instrumentation system, and it was powered by the engines. When both engines stopped working, almost everything went dark. Isn't that fun? The 767 had ram air turbines, or RAT, that swing out from the compartment, and they convert air flowing past the plane to rotational movement, which is able to power the hydraulic systems and emergency systems.
Yes, so ram air turbines, they're on essentially every jet aircraft that are out there, and what they are, they're essentially just like a pinwheel or kind of like a fan. It's kind of that's the shape, and they when you lose engine power, they'll basically fall out of this compartment, and they kind of drop into the airstream of the plane going forward. So it just kind of acts like a big water wheel, I guess. But the air goes over it, and you're able to generate power of various systems in the aircraft.
The captain of the Gimli Glider, Bob Pearson, had over 15,000 hours as a pilot, and he was also an experienced glider pilot, which is the perfect combination for the Gimli Glider. That's how it's got its name. So he knew how to fly the plane at the optimal glide speed that allowed them to have the maximum range and therefore the largest choice of landing sites. So there's an optimal glide speed and angle that you use to get the furthest range or to be able to fly the furthest with your glider. And he knew how to use the 767 in that fashion, which just gave them a lot of options as far as where they could land the plane, which is really, really good because they were able to find a safe place to, I think as they say, bring this bird down. So for every 10 nautical miles or 19 kilometers, they lost 1,500 meters of elevation, which gave them a glide ratio of 12-1.
Which I feel is actually really, really good for an airplane that is not designed as a glider. I did some gliding back in my cadet days many years ago, and so gliders that we used in initial glider training in cadets, they had a glide ratio of 22-1, if I remember correctly. So, like Nicole mentioned, it means for every 1 foot of vertical elevation that's lost, the glider goes horizontally 22 feet. So, things that are designed for gliding, even initial glider training aircraft, they have a much better glide ratio than a 767, which makes a lot of sense. On the gliders, like they're very narrow, they have very long wings on them. The ones that we used would seat 2 people, so 767 carries a lot more people. Wings aren't designed for gliding since it has powered, since it has engines for power, so you don't need to have kind of the same design considerations for that. And then dedicated gliders that are used for, kind of mountain soaring and ridge soaring and, professional gliding, they typically have a glide ratio of 50-1 to 70-1. So they are quite good at staying aloft. And here where Nicole and I live, just a little bit further south of us, there's a glider location that takes advantage of mountain wave, or kind of these big winds that will come off the mountains. And some of their gliders can go, they're some of them are pressurized, or guys will wear, heated suits, and they'll get up to, 20, 25, 30,000 feet gliding, which I think is quite remarkable, just by using the lift that's generated, from the wind coming over the mountains.
Like Brian said, 12 to 1, a glide ratio of 12 to 1, when you compare it to an actual glider, it's not great. But the fact that they were able to use the 767 as a glider, the fact that the pilot had that experience, knew what he was doing with respect to gliders, and knew how to utilize this plane in that fashion, I think was really impressive, and also very, very lucky for everyone on board.
One of the other things I think that also helped here is the first officer, Maurice Quintel. He had served with the Royal Canadian Air Force, and he was stationed in Gimli, which is just to the west of Winnipeg. What he didn't know, unfortunately, though, was that Gimli had been converted to a racetrack complex and drag racing there, and they had they got a road course and a go-kart track and a big drag strip. And at the time that this aircraft was landing, or that they were going to land, there was a race that was happening at the time of the incident, which I think is incredibly wild, because the 767 is not a small airplane. I mean, this is, it's, I'm sure many of our listeners have sat in one or have flown in one. I mean, this aircraft does transoceanic crossings. It hauls tons of cargo. It seats 300 people. And so to see this come out of the sky and attempt to land, or even be that low on a place that's not an airport, I think would probably be incredibly startling for all of the people that are attending, a car racing event.
Yes, we are going to get into the reaction of some of those such people shortly. There's a really, well, funny now, but maybe not funny then story. So without power, and this is also something you don't think about, so they lost all of their instruments. They had the ram air turbine that gave them some of that back, but not all of it. And on top of that, the landing gear needs power to go down, at least traditionally. They were able to use gravity to drop it, but they weren't able to drop it with enough force to lock it in place. The main gear did lock in place, so that's the gear under the body of the plane, but the landing gear on the nose did not lock. As the plane slowed down to land, the ram air turbine that they were using to control the plane was also seeing less air. And so as it was getting less air, it was reducing power, and that was providing a loss of controls that was just making the landing that much more difficult. They were also coming in a bit too high and too fast, and they tried to, quote, cross the controls by applying rudder in one direction and ailerons in the other direction, which is a forward slip, and this further impacted the ram air turbine. On top of that, as we mentioned, there's people on the ground. They're attending this drag race or this road race that's going on, and with both engines out, the plane made almost no noise to alert those on the ground that it was coming. So it's kind of like when you're driving down the road and Tesla's behind you. You don't hear it until you turn around, and then all of a sudden there's a car behind you. So they actually put noisemakers on them to simulate car noises so that people can hear them, because it's actually quite dangerous to pedestrians.
So the nose wheel not locking added friction when the aircraft landed, and it did help them stop a little bit. There was also a guardrail in place to facilitate the drag track, and they applied extra right brake, which caused the main landing gear to straddle the guardrail. So probably not the best landing that they'd ever done in their lives, but they did manage to get the airplane down on the ground in one piece, no fatalities, no serious injuries, which I think, given the circumstances, I think you got to call that a win.
Huge win.
Yeah, and there were two kids that were riding their bikes about 300 meters away from the landing site, and Captain Pearson said that they were close enough to see the terror on their face. Like, as a kid, that would be terrifying.
That would be terrifying as an adult.
But
Yeah.
but you're gonna have a really awesome story to go tell your buddies at school, or your coworkers, or your spouse, or the guy that sits beside you at the pub. Like, you have a story to tell for the rest of your life.
Oh, yeah. So we've talked about what happened, but we haven't really talked about why. Why did both engines fail halfway across the country?
Well, because they ran out of fuel, Nicole.
They ran out of fuel, yeah. So it's actually a very simple unit conversion error that was made that was, as usual, completely preventable. When they were filling the plane, they mistook pounds for kilograms. And so the plane only had about 40% of the required fuel load that it needed to make that flight, which is really unfortunate.
Yeah, and when this occurred, Air Canada was just switching over a lot of their systems from imperial measurements to metric measurements. So there are a lot of things that are going on that contribute to this.
Yeah, so this was early 80s. I think we talked about it on an earlier episode. Canada adopted the metric system, I think in the late 70s.
I believe it was 1976, somewhere around there.
So the plane, the Gimli Glider had a fuel quantity indication system, or an FQIS, and that had two redundant channels. But there was a design flaw that caused the entire system to fail when one of the channels failed. I think they entirely missed the point of redundancy here. That's literally the point of redundancy, is that when one of the systems fails, the other one keeps working. So the fact that they both failed anytime there was a problem with one was a big problem in my mind. Following a flight the day before the incident, an engineer in Edmonton ran a service check on the plane's FQIS system, according to a bulletin issued by Boeing, the plane's manufacturer. The system failed, which made the fuel gauges go blank as a result. Drawing on experience from a similar incident with the same aircraft a month prior, the engineer, in lieu of spare parts, fixed the problem by disabling the second channel and tagging the circuit breaker. He informed the pilot flying out of Edmonton the next day that the fuel would need to be measured with a float stick. However, there was a misunderstanding, and the information made it to Montreal and the change of crews in a highly muddled state. It's like when you play the game of telephone. The message that gets all the way across the channel is never quite the same as it was when it started. To complicate matters more, while the plane was on the ground in Montreal, a technician came into the cockpit and re-engaged the second channel of the FQIS. Meanwhile, he was distracted by the fuel tank outside and never removed the tag from the circuit breaker. This causes the fuel gauges to remain completely blank. So the pilots didn't even know that they didn't have enough fuel until the engines turned off. And even then, I don't think they really figured out what happened until after the plane had landed, if you would call it that. Another miscommunication led to the crew using only a dipstick measurement of the fuel tanks. The flight computer required the fuel quantity to be entered in kilograms of fuel, but the calculation was done in pounds per liter, and that value was entered. And that's why we ended up with only 45% of the fuel in this airplane. Once the plane would have made it to Edmonton, there was a crew ready to install a working FQIS they had borrowed from another airline. So they had a plan to fix this.
They just didn't quite arrive in time to implement the plan.
Yeah, and as usual, the best laid plans go awry, and so the communication didn't quite make it all the way across. We've seen this before. There's no clear process for communication and how things are locked out and tagged out. That's kind of what we saw with the Piper Alpha failure, which is not plane related, but similarly had some failures in their shutdown process and how issues were documented and passed on from crew to crew. The same kind of thing happened here, just a little bit different. As a person who converts units all day, every day, I do think this is a little funny because this is so common. There's also a Mars rover that we did on another mini failure episode that also had a unit conversion issue and went completely out of orbit, and I believe it ultimately crashed into Mars.
I don't think that's the only NASA-related probe or program where they've lost the craft at the end of the program because of a unit conversion error. So yeah, like Nicole said, we convert units all day, every day. I do a ton of unit conversion for meters to feet or kilograms to pounds. So unit conversion, especially in Canada, is something that I feel that we do a lot of just because we're so close to the States. I said it before, I literally have no idea how many meters and centimeters tall I am or how many kilograms I weigh, but I know exactly what my height is in feet and inches and how much I weigh in pounds. So I feel Canada is fairly unit flexible on things, but still it's very unfortunate that something so simple as a conversion error, a unit conversion error, did lead to this aircraft running out of fuel. Fortunately, nobody was seriously injured in this incident. This could have gone a lot worse, in multiple ways if the weather wasn't as good, or if Gimli wasn't there, or they had to run out of fuel at a different location, or the flight crew didn't have experience with glider operations. This could have gone very, very poorly. And it came from such a simple cause of not making a correct unit conversion, or even having somebody confirm the unit conversion and the quantity of fuel that should have been in the aircraft.
Yeah, I'd just like to point out that there are only 3 countries in the world that don't use the metric system, at least not officially. I think the UK is similar to Canada in that it has this kind of in-between system where they use different units for different things depending on whether it's temperature or weight or what have you. But yeah, I just like to say almost all countries use the metric system, and even within the United States, most people in a scientific field also use the metric system. So maybe we should just all adopt the metric system and we can avoid problems like this forever. That would be that's my recommendation. My official recommendation.
For anyone that's wondering, the 3 countries in the world that use the metric or that use imperial units are the US, Myanmar, and Liberia.
Yeah, and a little bit of the UK. I know they do use it some.
Yeah. So there's a board of inquiry that does get formed after the 767 incident, and the board of inquiry found Air Canada at fault for procedures, training, and manuals, which is not really surprising. They also make the recommendation that Air Canada should adopt metric units for everything, and having a kind of a fleet of aircraft that are working on metric units and imperial units, that was pretty dangerous, and I certainly agree with the board of inquiry on this one. The plane had already flown from Edmonton to Toronto to Montreal with a failed FQIS without incident. That doesn't mean that it was going to continue indefinitely not having an incident, and as we saw in this, it wound up having an incident. The misreading occurred once in Montreal and then again in Ottawa by the same captain who is not used to flying metric. And just to point out, this was the first aircraft in the Air Canada fleet to use kilograms on the fuel gauges, but the measurements needed to be entered in kilograms per liter. And the fueler who checked the float stick reported the density in pounds per liter, as was procedure for other Air Canada aircraft at the time. So we have a lot of different unit measurements and mixed units that are being used at the time. With airline operations, there's a quick turnaround time. Like the airplane lands, they have to fuel it. You have to get passengers off, passengers on. Like you have a schedule to keep. So some of this, I can see how it would get overlooked, and it feels like it was unnecessarily complicated. Anytime that there's something that's wrong with an aircraft, or something's deferred on the minimum equipment list, whenever you fly, as flight crew, I've always kind of taken a step back, or just been more aware of how that defect will impact the flight going forward, and just kind of take a little bit more time just to understand how it's going to impact operations.
I also think an important part here, and maybe this was the case and I just missed it in my research, but I don't think that the units were necessarily recorded on the measurement devices. I don't know if the float stick that was used or the fuel gauges that they were entering the data into stated the units on them. I think that's a really key factor here, or at least a key factor that I come across in unit conversion. It's like when you ask someone how long something is and they just say 7. Well, 7 what? Like, I need more data. What's 7 what? That doesn't tell me anything.
7 tomatoes, Nicole. It's 7 tomatoes long.
So I think stating the units on the devices that you're using is a key part to avoid this type of thing from going on, because then, if I'm entering it in kilograms per liter, then when they give me a number, I can say, oh, are you sure it's this? I think that would be helpful. As Brian mentioned, Air Canada was found responsible, and that was for corporate and equipment deficiencies. That said, the flight and cabin crew were praised for their professionalism and skill, and honestly, I'm still impressed about this one, that they were able to land this plane. This incident took place around the time flights were switching from 3-person crews with a flight engineer over to a 2-person crew, and we've talked about this before on some of the older plane failures that we've discussed, where they had a flight engineer who's a third person that sits behind the pilot and the first officer in the cockpit, and they're the person reading all of the gauges. That's now become automated, and there's a computer that does all that for you and provides the data, and so that third person is no longer there on the plane, or their job has now been replaced by software. The task of checking the fuel load was not properly reassigned from the flight engineer to someone else. So this is also a process failure that's occurred. There was a task that the flight engineer typically looked after, and that wasn't they changed some of the things to this software, but the software is not checking the fuel load, or at least not on this specific plane. And so that's something that should have been reassigned to someone, and clearly reassigned. You can't just assume someone else will take care of it. You have to say, okay, it was your job before and now it's this other person's job, and make sure that everybody knows that's happened. It was also recommended that Air Canada keep more spare parts in its maintenance inventory. Had they had the spare FQIS parts, the plane never would have left Edmonton with a faulty system, and this entire thing could have been entirely avoided. And it's challenging because you can't keep, you have to keep certain parts in your maintenance inventory, but you can't keep 100 of everything. That does become tricky. So I understand that it's difficult to manage your parts inventory such that you have the parts you need when you need them, and you're not storing things for tens of hundreds of years. Yeah, I think that just takes a little bit of finessing to find what that balance is.
As a result of this incident, Captain Pearson was demoted for 6 months and First Officer Quintal was suspended for 2 weeks. 3 maintenance personnel were also suspended. 2 years later, though, the pilots were awarded the first ever Fédération Aéronautique Internationale Diploma for Outstanding Airmanship, which I think is a very well-deserved award for their airmanship. Flying an aircraft, essentially gliding an aircraft from 35,000 feet down to the ground is not an easy thing to do. There were several attempts by crews in Flight Sim to recreate the conditions for this flight and see what the outcome would be, but all of the attempts in the Flight Sim, they did result in crashes. So the crews in the Flight Sim, even knowing that they would have this double engine failure occur in flight and familiar with the profiles for it, and they could, run a whole bunch of checklists and go over things, they were unable to land the aircraft in Gimli in the way that Captain Pearson and First Officer Quintal did. So I think that's quite impressive. The plane was temporarily repaired in Gimli and flew to a maintenance base in Winnipeg 2 days later for a full repair. It was then returned to full service with Air Canada, and in fact, you could have flown on this plane.
The Gimli Glider flew its last flight on January 24th, 2008 from Montreal to Tucson before retiring in the Mojave Desert in California. On board for its final flight were pilots Pearson and Quintal, and there were 6 flight attendants who were on the Gimli Glider that day that it landed in Manitoba. It was eventually scrapped for parts in early 2014, which is kind of sad. This plane is really cool, and I think it kind of deserves to be in a museum somewhere. But unfortunately, I don't own it, and that's not up to me, so it was scrapped for parts.
Yeah, it's always sad when aircraft get scrapped for parts. In California and kind of Mojave Desert and kind of in Arizona as well, there's a lot of storage locations for aircraft, so like old airliners and old military aircraft, and these sites are thousands and thousands of acres, and they have thousands of airplanes. I kind of like looking at pictures of some of these desert storage sites for the airplanes, and yeah, it's interesting the collection of airplanes that are there, but eventually most of them get broken up, sold for scrap, and disassembled and turned into various other things that we use in our lives. It's kind of the life cycle of airplanes. So there you have it. The Gimli Glider. Units are hard, but they're pretty important, as we've seen. What was thought to be a full refuel was only 45% of the required fuel load, leading to an emergency landing at former RCAF station Gimli that had been converted into a drag strip. This could have been a very tragic accident, but the pilot's glider experience saved the day and the lives of everyone on board.
For photos, sources, and an episode summary from this week's episode, head to failureology.ca. If you're enjoying what you're hearing, please rate, review, and subscribe to Failureology so more people can find us. If you want to chat with us, our Twitter handle is @Failureology. You can email us at thefailureologypodcast@gmail.com. You can connect with us on LinkedIn, or you can message us right on the Patreon page. Check out the show notes for links to all of these. Thanks everyone for listening, and tune into the next episode where we'll talk about Big Bayou Connaught rail disaster. And I mean it this time. I know I said that last time. I mean it for real this time. We are going to do Big Bayou Connaught rail disaster on the next episode. A barge ran into the rail bridge and knocked the rail tracks off course. But the inbound train had no idea what they were headed for. Bye everyone. Talk soon.